What's up guys, welcome back to Ubad's lab, and today I'm going to be working through another general chemistry problem, with today's question being a concentration of ions question. So let's say this is the information that we're given in the problem. So we have 30 milliliters of a concentration of 0.200 of CaC2H3O2, and we have 25 milliliters of a concentration of 0.400 of K2CO3. And then they're asking us for what are the concentration of everything in this reaction. So the first thing that we do to set this up is to make an equation. So we have Ca C2, H3, O2, and subscript of 2 plus K2CO3, and then that goes to K, KC2H3O2 plus CaCO3. Okay, so we have this reaction, but it's still not balanced since we have 2 Ks over here, 1 K over there, and then 2 of these over here and 1 of these over here, and we can easily balance this out by just putting a 2 over here. Alright, so now that we have the balanced equation, we're gonna have to find the moles of the reactants. So we're given the molarity and liters. So we know that molarity is equal to moles over liters. So we can just multiply the liters and the molarity to find the moles. So we're giving milliliters, so we can just turn it into 0.03 liters. So 0.03 times 0.2 is equal to 0.006. So this is 0.006 moles. And then for this one, 0.025 liters times 0.4, and that's 0.010 moles. Okay, so now that we have the moles of the reactants, we need to find out which one of these reactants is the limiting reactant. So we know that the ratio for this to this is 1 to 1, and this to this is 1 to 1 as well. So going from here to there will just cause the same thing, 0.006 and 0.010, okay? And we'll still have less of this no matter what, so we know that this is a limiting reactant. So we can label that the limiting reactant, and then this is the excess then. Okay, now that we have that, we can start off by solving for our first concentration. So we know that the concentration of whatever appears in the limiting reactant and then in the insoluble product has a concentration of 0. So Ca appears in this limiting reactant, and then we know that this is insoluble because it doesn't have any group 1 element or any of the other ions that are soluble. And we know that this is soluble since it has a group 1 element. So basically just in terms of memorizing your solubility rules. So this Ca appears in both of these. So we know that Ca has a concentration of 0. Okay, so we solved for our first one. Next, we can solve for C2H3O2, and we can do that by just, so C2H3O2 is equal to, so we're going to solve for the molarity, so it's moles over liters. So we know it's 0.006 moles, but we have to multiply it by 2 since there's a subscript of 2 there. And our new liters is the combination of this solution. So 30 plus 25, so we have 55 milliliters, and that's 0.055 liters. and that is equal to 0.218. So we have a concentration of 0.218 for this one. Okay, and now we can move on to our next concentration, which will solve for potassium now. So K is equal to 0.010, and that's still going to be multiplied by 2 since there's a subscript of 2 there, and then 0.055 because it's the same solution, liters, and that'll give us a concentration of 0.364. 0.364. Okay, so we solved those three. Those are 3 easy ones. Save the hardest for last, which is the CO3. That is whatever appears in the excess and appears in the insoluble compound in the products. So for this one, we're gonna have to find what the excess is. So going from the limiting reactant to the excess, it's a 1-to-1 ratio. So we'll have 0.006 moles of K2CO3, and we'll have to subtract 0.010 minus 0.006, and that gives us 0.004. So that's our excess. And then to solve for the concentration of CO3, we have to do 0.004 over 0.055 liters. And we don't have any subscript for the CO3, so we don't have to multiply it by anything. So we just divide this out, and we have 0.004 divided by 0.055, and we get 0.073. So now that we have the concentrations of everything, Ca is equal to 0, C2H3O2 is equal to 0.218, K is equal to 0.364, and CO3 is equal to 0.073. So we have all the concentrations, and we're done. Thanks for watching, guys. Don't forget to like, subscribe, and hit the notification bell if you enjoyed the video. Also, stay tuned for my next video where I extract manganese dioxide from batteries. Also, I just recently made a Discord that you guys should join. The link is in the description, and that we just discuss anything chemistry related or anything related to this channel.